Okay, so today we want to start looking at trigonometry. Trigonometry. So first thing first, you need to put a reality here. Important things that we are going to deal with. So we'll have one. So when you are studying trigonometry, one thing you should know is converting to or I say converting the radians to and from degrees. Second thing, quadrants. Quadrants. And then third, coterminal and reference angles. From there, you look at special triangles. Or special angles. And then some identities. Then you can now start solving trig equations so that you become very free even to sketches. So all these, so this is how you should understand trigonometry. Converting to and from radians degrees, that's an easy thing. And then you get an idea of what happens around the quadrants. In quadrants, you use coterminal and reference angles, and then you're able to understand the special angles that you bring around the quadrants. Then you can do some identities and solve equations, and then you're able to sketch. So that we can start in that pattern. So one, conversions.
Sir, just a minute. Can you give me just a few seconds? I just want to copy what you wrote there.
Okay. Do you copy your screenshot?
All right, done. Thanks.
So to convert from radians to degrees, use, so if these are degrees, a pi, these are radians, you want to take to degrees, you multiply by 180 over pi, because we are saying that pi is exactly equal to 180. And then to convert from degrees to radians, you use from theta degrees, you multiply by pi over 180 degrees. That's how you switch from radians to degrees, from degrees to radians. So now let's do examples so that you're able to understand what is going on here.
Sir, just repeat. Can I see your previous page? Okay, thank you.
One, convert the following to degrees. A, 4 pi over 3. B, 3 pi over 2. Then C, 7 pi over 3. Solution. A, you multiply 4 pi over 3 by, we are moving to degrees, so you multiply by 180 over pi, so that this and this can cancel. And then you have 3 in here, 1, 3 in 18, 6. So you get 240 degrees. Then B, you have 3 pi over 2. You multiply again by 180 degrees over pi. This pi is always to take away that pi, so that this 2 here, 1, 2 there, 9. When you multiply 3 by 9, you get 27. And then there's a 0 there. Then if it is 7 pi over 3, you multiply by 180 degrees over pi. So you see that this pi and that pi will cancel. This guy here 1, this guy there 6. 7 times 6, you get 42. So we get 420 degrees. That's how we do the conversion. Now, no one may ask you to do this in an exam, but you may be given a question in degrees, in radians, and then maybe you are used to degrees. So this is to help you be able to move the question from radians to degrees, do what they're asked to do, and then present your answer back in radians. Because if they say 7 pi over 3, even me, if I don't calculate, I won't know what I'm dealing with. So it's easier to quickly change. I have 420. Oh, I'm doing 420. It's bigger than 360. So what happens? We start reasoning that way.
Now, sir, why are we using 108 instead of 360?
No, because we are using we are using this fact here that pi is the same as 180. We know that 2 pi is exactly the same as 360. But if I'm using this, I can always simplify it. So it will come back to pi is equal to 180.
All right, thank you.
Yeah. So example 2, convert the following to radians. A 30 degrees, B 45 degrees, and C negative 100 degrees. I say, okay, the solutions for A, we are multiplying 30 degrees by pi over 180. So you can see that the 0 and the 0 goes, 3 here, 1, 3 here, 6. So we remain with pi over 6. To show that things are very, very easy now, you can multiply 45 degrees by pi over 180 degrees. 45 here 1, 45 here 4. So we get pi over 4. C negative 100 will multiply by pi over 180. So we'll have 0 there, 0 there. We remain with negative 10 pi over 18. 2 in negative 10, it goes negative 5. And 2 in 18, it goes 9. So we have negative 5 pi over 9. Well, this is not a very long story. It's as short as this, so that we talk about quadrants. Now the quadrants are of this nature. Very, very important. You start from 0 and breathe at 90. And call this the first quadrant. Pick it up from 90, you reach 180, you breathe, and this whole space is called the second quadrant. You move from 180 to 270 and call the whole space the third quadrant. And from 270 to 360, call this space the fourth quadrant. And since we have only 6 trig functions, sine, so we have sine, we have sine, we have cosine, we have tan, we have cosec, we have sec, and we have cot. All these, in the first quadrant, they give us positives. What we mean by first quadrant giving us positive, we mean if you pick sine 70, before you know its value, the sign of that value will be positive. If I pick cot 1, the answer will be positive. That is what the quadrants are telling us. So that when you extend in the second quadrant, you have only sine here and cosec giving us positive. The other guys will be quiet here, but if you touch them, they will give you if you try them here, you'll be shocked. You'll only be getting negative numbers. You go in the third quadrant, you find that tan and cot are very relaxed here. The only thing they give you is a positive number. But if you try to go back to sine and cosec, thinking they'll still behave in the same way they behaved in the third quadrant, sine and cosec will join cos and sec to give you negatives. So you say, okay, so like cos is used, it will be negative anywhere. You discover that in this section here, cos and sec are giving us positives. And the other guys, they are giving us negatives. This is very, if you want, you can get your calculators, pick any angle between 270 and 360. Pick 300, 301, 315, 271. Try to punch sine, cosec, tan, cot. What you get will be negative. So here we learn that all these trig functions, they only give us positives in two quadrants. Each has two negatives and two positives in the full quadrant, in the full circle. Sine in the first and second, meaning from 0 to 180, sine gives us positives. But if you go beyond 180 to 360, you get negatives for sine. Now, sine and cosec are related. Sec and cos are related. So we are saying only the sine and cos, these two guys are not directly related. But they give you tan if you take sine up and divide it by cos. Sine and cos can still give you cot. If you switch, you start with cos and divide by sine. If you just get cos and divide 1 by cos, you get sec. You get sec, and then you get cosec if you divide 1 by sine. What a nice topic. Just made by only two things, sine and cosine. So if I can pay attention to sine and cosine, I would have known everything. Because tan is just sine over cos. Cot is just cos over sine. Sec is just 1 over cos. Cosec is just 1 over sine. So if I understand sine and cosine very well, I'll have less difficulties in understanding the rest. So at this point, we can now introduce other terms like the coterminal angles. What angles are these? These are angles that share the same starting and end point. Now, these are angles, because they share the same starting and end point. You understand that if you go back to the quadrants, it means that they will start at the same point and end at the same point. So they will have the same starting point, same starting quadrant, same end point, same end quadrant. Meaning that if they give positive, they will give positive. If one gives positive, even the other must give positive because they'll be in the same quadrant. So we add to say they have the same properties. And how do we find them? So if we want coterminal angles that lies between 0 and 360. Say coterminal angles of theta. We obtain them in two ways. One, if theta is greater than 360, we subtract 360 from theta until we obtain an angle between 0 and 360. Another way is if theta is less than 0, we add 360 until, so we add 360 to theta until we obtain an angle between 0 degrees and 360. That is what happens. So don't forget, keep this information so that I add something about
So
reference
just
angle.
just a minute.
Yeah, just a minute. I'm asking for the previous page. I haven't finished writing.
Yeah, I miss you guys. The problem is that the rule of the people, for the people with the people, is becoming an issue.
All right, so you can move on.
Okay. There were so many voices, like they are all saying we can move on. Okay. So what is the reference angle? The reference angles are angles that lie in the first quadrant. Reference angles are angles that lie in the first quadrant. We obtain, so this means that they lie between 0 and 90 degrees. Okay. How do we obtain them? we obtain reference angles with respect to the quadrants. Let's see this. From 0 to 90, the definition says all the angles that lies here are reference angles. So if you are given x here and they ask you to find the reference, I mean if you're finding theta, the reference angle of theta, given x, what you're going to say is that x will be the reference angle of itself. But if you are given x in the second quadrant and they ask you to find the reference angle theta of x, you say theta is 180 minus x. Remember, our target is to find theta that lies between 0 and 90. So if an angle is beyond 90 but less than 180, the only way you can find the reference angle that is between 0 and 90 is to subtract 180 minus that angle. If that angle goes beyond 180 but less than 270, you know you cannot add here to find theta, because if you add, you have 180 plus. That angle is too far, much bigger than 90. So you subtract from that very angle, you subtract 180. In the fourth quadrant, you subtract from 360. Okay. So to now grasp the concept between coterminal and reference, we need examples. Yes?
I have a question. In the third quadrant, isn't it supposed to be theta is equals to x plus 180?
Remember what you have, where theta lies? Theta is here.
Okay.
So if you happen to add, even if you add a 0, it will be 180. So 180 is bigger than 90.
All right.
Examples. So that we enjoy now. 1. Find the coterminal angle of A negative 100, B negative 60, C 400, D 920. Maybe we put another one. E negative 404 or 405. What are we looking for? We're looking for coterminal angles. And what are coterminal angles? So in this case, we must give, so whenever they ask you for the coterminal angles, they'll give you an interval where they must fall, because there are so many. So find the coterminal angles. Let me give an interval between 0 less than theta less than 360. Or I can even do the equal. Find coterminal angles that fall in that interval. A we said whenever theta is less than 0, we add 360 to theta until we obtain an angle between 0 and 360. So we want the coterminal angle of -100. So we'll call the coterminal angle theta, or we'll call it x, so that there's no confusion with our definition. So we'll say x is going to be, since our theta is -100, we must add 360. And what we'll get is 260. This falls in the interval 0 to 360. So we have found the coterminal angle of -100. B, x will be -60 plus 360. So we'll get 300 degrees. As our coterminal. Hello.
So it's all the negatives. It goes up to.
What's your question?
I mean all the negatives. Does it mean it goes up to 360?
All the negatives.
The angles.
We only have two conditions, 1 and 2. If theta is bigger than 360, you subtract 360. If theta is less than, we add 360. So if you have a negative number, you add 360
Okay.
to all the negative numbers.
Okay.
Let's go to C. We have 400 above 360, so we'll subtract 360. So what are we getting?
Conditionally.
Can we mute?
We are getting 40.
So we'll get 40. If we go to D, we have 920. So we'll subtract 360 and see what we get. Here we'll get 920 minus 360. That is 0.6. 8 minus
560, sir.
560. Still bigger than 360, so we subtract again. We'll get, at least now I'm sure it's 200. It falls now in the required interval. So we leave it there. So we don't stop subtracting until we get to our required interval. For E, it is -405. So let's add 360. What do we get?
-45.
-45. It is negative, so we keep adding. And we get +315. It becomes our solution. That is what we call coterminal angle. So these angles, if you are to draw, we demonstrate for 1. Let's demonstrate for -100. -100 comes like this. It is 100 somewhere here. So this whole angle is -100. Because the negatives go in reverse. Then +260 starts from there This one here is positive 260. So if you can see, they start from the same point and end at the same point. So if it is 920, if we demonstrate for 920, 920 goes once, you reach here, it is 360. It goes again, you reach here, it is 720. Goes again, you reach here, it is 920. But 200 also start from there and end here. So they are coterminal, starting at the same point, ending at the same point. And you see how we use them, depending on the questions that we meet. Okay, then another example, example 2. Find the reference angle of A, negative 60, B, negative 100, C, 420, D, 225, C, 315. Let's see after D. F, 120. Solutions. There's a question, Zari.
Sir, can you also include maybe just one example of radians?
Of the radian.
Yes.
Okay. Okay. So A, B, C, D, E, F, G. Negative 3 pi over 4. So I'll see if there's need for more. A.
Sir, kind of, but you haven't indicated the interval.
For reference, no interval. Their definition is an interval already. So A, we want for negative 60. The first thing we do, since by definition we say that reference angles are angles that lie in the first quadrant. Now negative 60 is not anywhere catered for in the formula here. We have angles from 0 to 90, 90 to 180, 180 to 270, 270 to 360. So we have no negatives here. Okay, but we have seen that coterminal angles can actually move from negative to positives. And since they share the same properties, what we'll do is when you're looking for a reference angle of a negative number, you first get its coterminal angle. So if we add here, we'll get 300. We get a coterminal angle that is between 0 and 360. Now 300 and negative 60 behave in the same way since we said that they have same properties. This means that the reference angle of negative 60 is also a reference angle of 300. Now 300 lies in the fourth quadrant. And how do we get reference angles in the fourth quadrant? We subtract from 360. So we'll say theta here, the reference angle, is going to be 360 minus 300, giving us 60 degrees. You go to B, negative 100. The temptation here is, just because for negative 60 we have gotten 60, you begin to think that every negative, you just throw the negative and make it positive. It's a reference angle. Let's see what happens to negative 100. So for negative 100, it's negative again. So we first add 360. It becomes 260. Now 260 falls in the third quadrant. So to get a reference angle in the third quadrant, you say 260 minus 180. And this will give us 80 degrees. So now we have seen that when it is a negative, we don't just throw the negative and make it positive and call it the reference angle. No, we need to calculate. The reference angle of a negative will come from its coterminal angle. Another question, yes?
Sir,
Hello.
would I be wrong to say, okay, it's fine.
All right. 420 is again not catered for on the definition of reference here. They end at 360. But they are dealing with 420. So what we do is we get its coterminal angle. So we subtract the 360 and get a 60. Now what's the reference angle of 60? The reference angle of 60, because 60 falls in the first quadrant, it is 60 itself. That's simple. 225 lies in the third quadrant, so the reference angle is going to be 225 minus 180, so that we get 45. 315 lies in the fourth quadrant, so it will be just 360 minus 315, 45. So what is happening is that if the angle falls in the quadrants, the non-quadrants, first, second, third, fourth, we just bring in the formula. No need of coterminal because we are within the required range. If 120 lies in the second quadrant, so you say 180 minus 120. This is giving us 60. G, we are dealing with negative 3 pi over 4. Well, I can't really tell whether this guy falls in the first quadrant, second, or fourth. But again, it's negative. But what value is it? I don't know. I can decide to change just here, to change it to degrees, and work with 180 over pi. So that this guy goes 4 here. So I'll have difficulty. So I'll say 2 here, 2 there, 9. So 2 here, 1. No, it cannot go now. Anyway, it can 2 here, 1, 2 in 90, 45. 45 by 3. We get negative 135. So this is the angle that we're dealing with. It's negative, so we add 360 in search of its coterminal angle. So get that is 25 there, So get 225. The reference angle of 225 has been found somewhere here. It is 45. So theta is 45. So the reason why I taught you how to convert is so that when you see what is strange, you convert it. So when you are still here, all of you, is it an issue guys having a class in the morning? Like before your lecture classes start?
Not really. They're part time.
Not really.
To the time.
Hello, sir.
Hello.
Yes, sir, I have a question. On your previous,
Ask.
yeah, you said like the times when the coterminal angles are more than one. So what did you go about that?
You are trying to?
There are times when the coterminal angles are maybe more than two. So what do you need to solve for the
No.
issue?
The interval will be given.
Yeah, yes, sir.
In each coterminal angle, in each interval, you only have one coterminal.
Oh,
Yes.
okay, sir.
So look, in days like, because during the day you hear I have a lecture, I have a lecture, I have a lecture, I have a makeup, I have what?
Sir,
Uh,
sir, I would suggest how we communicate in the morning, not early in the morning.
okay.
Because some of us is in the morning, some in the afternoon. So there's we can
Okay, so let's do this. Let's allow only the person talking to be unmuted so that the backgrounds can be clear. So we all mute and then one at a time. So you can start. Who was on the floor?
class in the morning because some say in the afternoon, some of us see it as a class. Can in the morning, not at least mid morning.
Okay, not early in the morning.
Not in
Okay. Okay.
Again, not more than 10:30.
Sir,
Yeah.
I think the timetable for the last time was better, like for 18, maybe up to 20, or 17 up to 20. Because from morning up to maybe 16, 17 hours, yeah, there's some classes which take place. So I think for 18 to 20 was just okay with me. Perhaps for girls, maybe.
Yeah, they already said they cook, but we could borrow. So we could ask the ladies to give us at least 2 days for 18 to 20. And
yes,
then
for 18 to
when they give us that time, so like tomorrow is Wednesday. So like Wednesday, we can have from 18 to 20. And also Thursday we can have from You can push a bit. I hear what they will say. 19 to 21.
Why can't you put it maybe 17, 30?
Now we're coming back. So now we come back to Monday. Monday, maybe if you can allow us 14 to 16.
Monday. No, try in the morning.
No, like on Monday, so I'm having a class at 15. At 15, I mean.
What
What about 7 hours?
10 to 12 on Monday?
No, sir.
No,
No.
no, sir. Just 7.
7 hours, sir. Monday,
7
7
hours.
hours.
The females have chosen.
Have chosen, have some camels.
What about 8? What about 8 to 10?
That's fair.
8, we're having a class, sir.
Okay.
I'm having a class at
That
10.
time.
This is still Monday. 16 to 18.
Yeah, better.
That's fine.
No, sir. 16 to 18, we've got physics at 17, finishing at 18. Not possible.
Hello, sir.
Hello?
Yes, I think for Wednesday for me, it's not favorable, sir. So I'm kind of asking me if you can push it maybe from 16.
That
If
is
it's
for you.
okay with others. Huh?
16 is fair. Wednesdays, we don't have physics on Monday and Tuesday, 17 hours, 17 hours.
What group are you in?
Okay, look. So we haven't fixed. We're suggesting Tuesday.
Sir, you can stop recording.
Oh yeah, so that the video won't be that much, is it?